Let's talk about linear regression and residuals. Let's do this with an example. Let's say you are a scientist and you happen to be studying, let's say, the Japanese beetle. You're studying the beetle here, like so. And you want to predict how many beetles. Okay, so you want to predict how many beetles there will be in, let's say you're studying ash elm trees. So you're trying to predict how many beetles there are in a particular ash elm tree based on the size of the ash elm tree. So let's say the thing you can measure is the circumference. So your predictor will be your number of beetles, and what you want to predict is your number of beetles, and the thing that you're going to use is the circumference, right? So first things first, let's think about this logically, right? So here in this situation, my circumference is my explanatory variable. This also means it's going to be my x. Whenever you have an x or x and y in an equation, your x determines what your y is. Your x is always going to be your constant force. This thing that's independent, it moves along at its own pace. It doesn't rely on the other. So my circumference is going to be my x. However, so then the number of beetles, well, that is going to be my y variable, or in this case, my response variable. And if I think about it, right now, if you think about it, so what kind of slope do you think we're gonna get if we have to think about it logically? Well, if you had a smaller tree, wouldn't we have less beetles? But likewise, if we had a bigger tree, we'd have bigger beetles. So if I were to draw like a rough graph, it'd probably be this. So I'd imagine the slope would be positive because it requires to have a bigger tree to have more beetles in it, logically. Also, then if it's with a positive slope, since this would be my y, this would be number of beetles right here, and this one here, circumference, usually a circumference is in inches, so inches would be my unit. So it'd be for beetles per inches would be my unit. Now let's say we went and got some data and we got an r squared variable, or your residual variable, and it is, let's say, 25.3%. What does that actually mean? What that means is that a linear model, right? So a linear model, if I had to write in a sentence describing what that r squared means. So a linear model on the circumference, of a tree accounts for 25.3% variation in the number of beetles. So what does that mean in terms of correlation? Okay, so our r squared here is variation. And variation is basically, if I had a line and I picked a point, right, it basically says from the top of the points, there's probably some points at the top, there's probably some points at the bottom. The top, it's positive and negative. So the variation is taking all the probability, or not just the probability, but it's the average of all of the possible either positive or negative values that you could have from your actual line of regression. So it's r squared because in mathematics, your positive and your negative will cancel each other out. Well, in this case, we don't have right, a zero variation. There's an actual a top and a bottom from our two different points. So that's why we use an r squared, because once you square any number, they both become positive, and that is then the variation, which allows for it is the average of the differences between actual numbers to your model number. Okay, so now from there we want to go on to think about that in terms of our correlation. Our correlation in this case is our standard deviation. Okay, which is basically the square root of our variation. So to find the standard deviation, so the standard deviation is the actual amount, the precise amount from the actual line one way or another. Because when we're dealing with standard deviation, we aren't trying to take in all of the amounts. We're just trying to predict one particular amount. So standard deviation can have a positive value and a negative value. So we go back up to our number, our 25.3 to find that. Remember, percent, it's actually 0.253 to find the correlation. We just take the square root of that. And from that, I get a 0.5 in terms of my standard deviation. So that means for the circumference, my standard deviation is 0.5 either up positive or 0.5 negative. Okay, so let's say I was given from that, we got an actual linear model. Let's say our linear model is beetle equals negative 1.29 plus 11.89, and then we'll tie a circumference, right? So shorten that. Of course, here we do start off with a negative. I want to point this out. We have a negative as our y-intercept. That means that there's a possibility for a negative beetles, which cannot happen, right? So this negative is not really arbitrary in that way. It is saying that here, so what we want to think about that here is like, oh, we don't really have negative, but it's probably just zero. Like at some point, the tree is so small, it's not going to have any beetles on it. It's at a certain point when a tree gets to a certain size that it starts to have beetles on it. Let's do some sample equations. So let's say we had a tree, what would we predict? So how many beetles if the circumference of the tree, let's say it's the circumference is, let's say it's a wide tree. Let's say it's a moderately wide tree. Let's say 3 feet wide. In this case, we are working with inches, so 3 feet is actually 36 inches. Let's put in our equation. So in an infected tree that is 3 feet wide, we'd imagine to see 426.75 beetles, or 427 beetles, right, in that tree.